So that tells me that the edge detector is a problem. So looking at that, there we go. I played around with it a little. So this was using the solution 3, which in this case I use a bunch of stuff, but if you look at the directives, there are two types of there are several directives here. The first, the stream directives, in and out. Those are actually quite important because when you look at solution 1, which has no directives, and you try to use it, you're going to get a whole mess of inputs and outputs. What these directives do is group them together as on the AXI axis fashion, AXIS. So you get them grouped as we saw in the diagram, in the block diagram. Without it, that's not going to be the case. So I tried some other things, unroll, data flow, latency, and nonetheless, I was getting really poor timing. Now, data flow and pipeline is similar. They're both involved with trying to, remember we talked about pipelining in a previous video where you put things in and they can wait there while you start processing the next thing. So, it is, at any rate, there are two different types of ways of doing it. So they have two different pragmas, data flow and pipeline. So data flow is the one they told you to use, and it allows functions and loops to overlap. Again, this is a way of multitasking. And they have a little picture here. So you can start things. Again, it's your starting function A. You can start function B, function C, before function A is completed, rather than B and C. The other one is pipeline. And pipeline is also, and that, remember we talked about the initiation interval, and that's how long it takes before you can work on the next piece of data. So, again, this is concurrency, and you can see here how they, how you can read, you can see it's starting the next read. So they're similar. They're not exactly the same. What I found, let me go back. What I found when I used pipelining, notice that the estimated performance for the clock was lower and it was within bounds. When I use directive, this is synthesis report. I gotta make sure I have the right solution. Yeah, this is solution 3. When I use this, in solution 3 we do use the directive, we use the data flow directive rather than the pipeline directive. You notice it's a lot higher. Now we also put some others in, unroll and latency. So solution 2, we did get it, and with the directives, just the interface and the pipeline. But you know what? To be fair, let's go back here and we're going to do unroll, and we're going to do latency. See what happens. See if we get what kind of timing we get here. So solution, run C synthesis, select solution. We're going to select solution 2. And see. Now remember last time it was within, that's solution 3. Well, it was within the target. So it worked out pretty well, but doing it the way that they suggested initially, with data flow, we were not getting great results. Nonetheless, whichever one I tried, it didn't seem to matter. It would not work. And notice even without going back here, let's go back to even without the, let's make this a little smaller so you can see, it got failed timing either way, but this one worked. So clearly the issue had to do with the new IP that we created. And it's still, what are we doing here? Solution 3. So it's still going here. It is creating it. So, in the end, what we found is the issue appears to be with the edge detect. If you take out the edge detect, it works fine. Now you can see I got pretty much the same results with adding those additional directives. In fact, it said it discard latency. That's interesting. Unable to satisfy pipeline directive. So even this is not great. It says that it exceeds uncertainty plus estimated adds up greater than the target. So ideally what you want is you want these two numbers to be less than the target. And as you can see here, this was really, and you look at the latency, 931, and you look at the latency here, it's, I'm wondering if it's even bigger. So this latency, and it can get into, so hard to tell. Now let's talk about probably the most valuable thing of this exercise is understanding performance. Remember, this module, this edge detection module, did not work. We put it in, quit working, took it out, it worked. So that points to something wrong with the design. We used the directives they specified, and that didn't seem to help. So I done a little experimentation as we looked at, and right now what I want to do is first of all discuss these reports, because if you were going to debug and try to figure out what could be the problem here, I think it's that there's got to be some performance issue, because the code is like 3 lines. I mean, if you look at the code involved, it's basically saying that you've got stream, defining these as streams. Then you're saying take the stream in and the image and change it to a format, then pull in the frame, convert to grayscale, run the edge detection, the Sobel option, the Sobel algorithm, convert it back to RGB, and then put the frame back in there. So there's not enough code there to have a bug. I mean, seriously. So it comes down to implementation. And as you remember, we talked about in the past, the trade-off in working with these FPGAs is performance versus space. And that's what these synthesis reports show you. Now this is the one for, looks like solution 2. And then I have another one with solution 3. And if you look at solution 2, and you look at their directives, they both have the stream in and stream out. And as I mentioned, that's so you don't get all these separate ins and outs. You have your AIX set up properly, and you can just connect it. Unroll is to unrolling loops. I don't know if that's going to do anything, because there really aren't loops necessarily here. And data flow, again, is trying to reduce latency and increase performance by starting on the next thing more quickly while the other one's still processing. So, and pipelining, which is what I used in this one, in solution 3. Pipelining. They're a similar type of thing, and they have documentation. I'm going to include a bunch of links that go into it, but let's talk about the major terminology we're going to see here. So, as I mentioned, it's a trade-off between area, resources, and performance. So area, when they talk about area in one of these reports, they're talking about the hardware resources that are used to implement the entire design, to implement the design based on the FPGA. Lookup tables, registers, block RAMs, and DSP-48 are a special type that Xilinx is special computational block. Latency, and we've talked about this before, latency and an initialization interval. Again, latency, number of clock cycles for the function to compute all output values. Initialization interval, how many clock cycles before the function can accept new data. Loop is iteration, and and initialization interval, a latency and initialization interval are basically the same thing for a particular loop. Now, it's loop iteration latency, which is how many clock cycles it takes to do one loop, and loop latency, the total for all the iterations of the loop. So this is the terminology that one needs to understand in looking at these reports. So let's go to solution 2 here. Now notice the clock target was 667. This is over. This is pretty similar to the one that they specified. And you can see the minimum latencies are not, looks like 931 clock cycles. And they go into the latency interval, the clock cycles for each of the items in the algorithm. And we're using data flow here. So you can see in loops, it's not part of it because we don't have any loops. Now this is your utilization, and it doesn't use a whole lot. It uses some LUTs, some flip-flops, I assume, some of their computational modules, a little bit of VRAM. So this is the solution with the data flow. Now when I did pipelining, as you can see, the estimated was lower. So, however, the latency was actually greater, the interval was greater, and actually used more resources. It's kind of interesting that the interval and the latency would actually go up. But then again, I'm using pipelining. I'm not using, there's something akin to the data flow. Although I thought they were pretty similar if you read the definition, what the purpose of them is. So I actually am curious what type means in that case. But at any rate, you can see it also breaks it down by here in the data flow. And if you think about it, it is talking about the data flow. It goes in, it moves through, it processes, it comes out. In solution 3, where it's focused more in the detail on the different modules and the loops. It doesn't look like it was able to do too much with the pipeline. So that was probably a pretty useless item. But it's kind of interesting that it came closer in terms of time. And let's look at utilization. Instance. So this actually used fewer instances. A lot of LUTs here because we're pipelining. Some more VRAM. 3 of the special. But you can tell it barely. This algorithm is so simple, it barely touches the surface with this device. So, at any rate, you can get an idea here of how these different things impact. I'm going to include a bunch of links that go into more detail. And next time, what I'm going to do is I should be getting any day now the Fire Ant FPGA. And we're going to take a look at that next time. I think it's interesting because they're real tiny from what I can tell. And which means you can, it's kind of like if you're familiar with the Adafruit products, they're kind of an FPGA version of some of their teeny tiny dev boards. So I'm going to be curious what can be done with it. And we will see. At any rate, I hope this was helpful. Like I said, you would use these reports and play with the different directives to try to get the time down and get it operating as efficiently as possible. And that may or may not fix it. It could just be some incompatibility with the newer software. And that I'm not sure of. But anyway, thank you very much for watching, and I will see you next time.